So today we start proofs, all right? So our common core is geometry, okay? Part 9, it basically says we're going to prove theorems about lines, angles, and planes, okay? So we start out today, it won't look like anything, it won't look like geometry at all. It's just basically doing an algebra proof. But this is the best way to start because algebra, you could do algebra. So whenever you do a proof, this is called a two-column proof, all right? So we draw the columns. We always put statements here because this is what we're going to state. Katie's guilty. Then we got to have reasons to back it up. Okay, well, obviously I don't have very good reasons, but we will have reasons to back it up. So whenever we do a proof, the first thing we do is we draw our two columns. We put statements here and reasons here, okay? Because you're going to have to do some proofs on your own. Now, you have to be given some facts, all right? Here's the first thing. We're given that -5 is equal to 3n plus 1, okay? And what we're going to prove is that n equals -2. So we're going to do a process of solving on this side. But on the other side, we're going to say what we did, all right? So it's really pretty simple. Always, first step of every proof, always, is to write down the given. Step 1. So you can have several steps. So this is always first step. Step 1. Go put a 1 right there. Always step 1, write down the given. I'm just going to go -5 equals 3n plus 1. Always. So on any quiz that I give on proofs, everybody should get the first question right. First part right. Agreed? I mean, everybody should. And what's the reason for it? It's given. It's like collecting your evidence. This is my evidence, okay? It's part of what I can have. Now, in this problem, we're just going to solve it. Okay, and as we solve it, we have to just go ahead and say what we're doing. So for the first part, I'm going to subtract 1, right? -1, -1. So step 2, after I go -1, -1, is going to be -6 equals 3n. Now in proofs, they won't show the -1, -1. If you want to show it, that's fine. They won't show it. They'll go from here to here, and then they'll say the reason is subtraction. You ready? Where's my rules? Subtraction, property of equality. Basically, we're subtracting, so we're going to say subtraction, property of equality, okay? So we're going to say subtraction, property of equality, okay? And I always abbreviation. I will always abbreviate, okay? Step 2, sorry, that's a step 2. All right. What would be the next step for solving this? Yeah, divide by 3. So divide by 3, and you get -2. You will not see the book show the step. They'll just go straight to it. So step 3, you'd wind up with -2 equals n. And what do? We divided, right? And so if we look at our little rules, division, property of equality, right? So 3, division, property of equality, okay? Now, what do we need to prove? It's a little bit tricky, but we have to be exact. Even in the court of law, you have to be exact, right? Because if you don't prove it exactly, you might get thrown out. I don't really want to prove -2 equals n. I have to prove n equals -2. It's a little bit different, isn't it? It's a little bit different. So what we do is we actually have a rule that says something like that. If a equals b, then b equals c. So I'm going to do the same thing. If -2 equals n, then n equals, here it is. If -2 equals n, then n equals -2. So I'm going to turn it around. This is called the symmetric property. So if I go from a to b equals b to a, it's saying the same thing, but we're just turning it around. So I'm going to rewrite this as step 4. Instead of -2 equals n, I'm going to rewrite it as n equals -2. All right? Saying the exact same thing, but saying it different. All right? The reason for that is the symmetric property of equality, okay? All I did is rewrote it. If -2 equals n, then obviously n equals -2, but the process of doing that is called the symmetric property of equality. Okay, there it is right there. Okay, if a equals b, then b equals a. We're saying the same thing, it's just turn it around. See how that property works? Okay, you're done. We have proven what we set out. So the very last step should always be this, shouldn't it? Because that's what we want to prove. All right, sideways thumb. Thumbs up, thumbs down, Okay, good. A lot of thumbs up. That's good to see. Okay, example 2. So in example 2, the difference is we're going to start off with a geometric figure, and then we're going to have to put in some x's, right? So what's the first step? Is always the given. So it's given in terms of letters. Km, which is the entire thing, is equal to KL, this piece, plus this piece. Okay, that makes sense to me. But we know, at least I've told you, the very first step is always, this is always the very first step. Write that down, step 1. Km equals KL plus LM. That's always the first step you write, is the given. And the reason for that, it's given. Okay? So no one should miss step 1. No one, right, Jade? Nobody should ever miss step 1 on any proof, okay? Now, what we need to do is get it from K's and M's and L's to X's and Y's. So we're going to do a substitution, all right? We're going to do a substitution. What I know is that Km is really equal to 5x minus 4, right? So instead of writing Km, I'm just going to go step 2. I'm writing in its place, I'm going to substitute 5x minus 4. Okay, because I need to get it from letters to some kind of equation, okay? Equals KL, KL is x plus 3, plus LM, which is a 2x minus 1. Okay, so that reason is substitution. We substituted. So writing the KMs and the KLs and LM, we substituted in what they were equal, the x's, okay? So that step is called the substitution property of equality, okay? So I just substituted. So we have to give the reason. The reason is the substitution, okay? Now I'm going to start solving, but before I solve, I'm going to tidy it up. Meaning I'm going to go ahead and I'm going to make sure I put the x and the 2x together. I'll put the 3 and the negative 1 together. So I'm just going to tidy it up. So step 3, I'll put a 5x minus 4, and then I will add x and 2x and make it a 3x. I will add a 3 and a negative 1 to make it a positive 2. So that reason is just the addition property. Okay, the addition property. I did not put of equality because I didn't do it over the equal sign. I just added, right? I just added. I just simplified, okay? And I didn't put of equality because I didn't do it to both sides, right? Okay? Now, let's solve. So next step, what would you do to solve?
Subtract 3x from 5x.
You guys agree with that? Minus 3x, minus 3x. If I go minus 3x, I will have a 2x minus 4 equals 2. And the reason for that is exactly what you said. It's the subtraction property. We subtracted. But a subtraction property of equality because I did it over the equal sign, okay? Subtraction prop of equality, okay? Next step, add 4. So step 5 would be 2x equals 6. And again, you won't see the book showing the steps. You'll just go to it. And since we added 4 over the equal sign, we're going to call it simply the addition property of equality. Okay, and if you abbreviate, that's fine as long as I can figure out what you're saying. Okay, does that make sense? Don't abbreviate so much I don't know what you got down there, okay? Last step, divide by 2, right? So we divide by 2, x equals 3. And again, it's just the division property of equality, okay? Not too bad. Thumbs up. Sideways. Where are we at? Okay, a little bit, almost. Okay, good. Okay, ready to turn the page? All right, last one. Okay, we got the same type of thing. In fact, this one's very similar to what we just did, but it's good to do it again, all right? So, what should we do? What's our first step? What's our first step? Write the given. So step 1, let's write down that angle ABC is equal to the measure, that should be measure of angle ABD plus the measure of angle DBC. And the reason? Given. Nobody should ever miss step 1, right? Given. You should always get step 1. Now, what you're going to find, the book will periodically give you more than one given, and then they'll put the given in different places, but always first step given, okay? Okay, so step 2, what should we do? Let's get rid of the A, B's, and C's. What do we want? What do we really want? Yeah, we want to get X's because we want to prove X equals 11. This is what we're trying to prove is X's, not A, B's, and C's. So let's substitute. Claire said let's get rid of the A, B, C's. So angle ABC is equal to 8X. So we'll write 8X right there. Oh, that's a bad looking 8. Equals, let's write instead of A, B, D, let's write the 3X plus 5 plus, instead of D, B, C, 6X minus 16. What's our reason?
Substitution is equality.
Yep, perfect. Substitution property. I wish I was a neater writer. Substitution property of equality. Okay, everybody agree with that? Sorry, it's so sloppy. I'm working on my handwriting. Okay, step 3. Let's tidy it up. 8x equals, let's see, how about a 9x, 3x plus 6x and 9x. 5 plus a negative 16, I think it's a negative 11, right?
Yep.
Okay, and that's just going to be addition property. Step 4, what are you going to do? Let's go minus 9x, so we agree with that. That'd give me a negative 1x equals negative 11. Step 4, that would be my my addition. Nope, my subtraction. Subtraction property of equality because I subtracted 9x. Last step, what am I going to do? I'm going to divide, right? I'm going to divide by negative 1, divide by negative 1, I get x equals positive 11. So step 5 is going to be my division property of equality. All right. Page 107, 3 to 15 odd.